All right, what we're going to do now is known as an info gap. It is a better activity to do when we're actually in class with each other, but we make do with what we have. So basically what we would do if this was in class right now is we would be given a problem card to one student and then a data card to another student. So the student with the problem card has a couple questions for them. So in this case, they tell us that weights for two different populations of African elephants at different locations are recorded. A, which of the populations has a heavier typical weight? Explain your reasoning. B, which of the populations has greater variability in weights? Explain your reasoning. So what we want to do here is design questions that we could ask someone if we wanted to answer these questions. Because this person over here in the data card, you can't see it, I have it blocked off, but they have a plethora of information that we want to get about these elephants. So we have to know the questions to ask to get that info. We can't just ask them which has a heavier typical weight. They're not going to do that. They're only going to recite back data. So we have to know what data do I need to know to answer these two questions. Okay, so let's focus on A first. Which of the populations has a heavier typical weight? Explain your reasoning. So let's focus on that one first. I'd like you to come up with two questions that you would want to ask, at least two questions, someone if you were trying to find out if something has a heavier typical weight. And really the key word there is typical. Okay, so hopefully that word typical to you means a measure of center. So what a measure of center is mean or median. Typical means something that happens on average. So one question you're definitely going to want to ask is, what is the mean for each population? Let me move this over. What is the median? All right. Another question that's very important when we talk about measure of center is the distribution. If it's skewed to the left or to the right, that's going to tell us something about our mean and median. So what is the distribution? All right, so for talking about center, those are really the only ones I would be thinking about when I'm talking about typical. But maybe you guys came up with some other ones, we'll see. All right, so for B, which population has greater variability in weights? Explain your reasoning. I'd like you to come up with at least one question you could ask someone if you wanted to know something more about variability of populations. Okay, so there really are two measures that we have so far when we talk about how variable something is. The first one is standard deviation. Large standard deviation means that it's more spread out. A small standard deviation means it's more together towards the middle. All right, we could also ask about the IQR. If we knew the IQR is larger for one, that's usually a pretty good sign that it is more variable. But again, it depends. We've seen situations where standard deviation is a better measure of a better measure of variability than interquartile range, because there are some ways that interquartile range can be not so reliable. In our last lesson, we showed that the IQR is really just based off two values, Q3 and Q1. And those values could really be, they could be unchanged by the rest of the data. There are only two values in a whole data set. whereas standard deviation is based on every single value in a data set. Okay, so let's see what kind of information we got. All right, so we got pretty much, I mean, obviously I saw the answers, but those are really all the questions we could have asked. All right, so the first thing we want to answer is which has a heavier typical weight. So the first thing we want to know is which is more appropriate in this situation, the mean or the median. And the answer to that is because it's symmetric, we really could use either one. And we can see why that's the case here. Even though my median is slightly above my mean here, which means that it's slightly skewed to the left because my mean is being brought down. So it's not actually perfectly symmetric. It's pretty close. I mean, we're only off by like 150 pounds, and we're talking about tens of thousands of pounds. But it is slightly skewed. This one is far less skewed. You can see the mean and median are very, very close, only 40 pounds away. But still, neither are very large. However, both of these mean and medians are around 10,400, 10,500. And this mean and median are 10,000, somewhere in the middle, 10,800. So population A has a heavier typical weight. Okay, now we want to talk about variability. And this is going to sort of play into something I was alluding to before about whether or not it's appropriate to use interquartile range or standard deviation. So we can see here that we've got a bit of an issue. If I look at the IQR for population A, and then I look at the IQR for population B, we can see the interquartile range is greater for A. So that would imply that it's got greater variability. Sorry, getting put off here. There we go. If I take a look at standard deviation, the standard deviation for population A and the standard deviation for population B, I've got 1,213 and 1,379, so B would be greater than A. So here again is a situation where we have an inconsistency. So it's not going to be so easy to tell which one has greater variability. But if we do remember that last activity in 12.3, if you look at a box plot, right, this IQR is only based on this middle part of the box plot. I could have very long, min and maxes that are very far away, which would increase the variability that this IQR cannot even comprehend. So that's why I say that standard deviation is more reliable. So we are going to say that B is more variable because of the standard deviation. Okay, so that's why it's important to check both. If we don't know the standard deviation, if we can't find it out, the IQR is not horrible. And we can see that like these standard deviations are not super far apart. The IQRs are not incredibly different, but they are slightly different. And if we were to compare them, we would want to say population B is more variable. Okay, problem card 2. I hope I didn't give away. That's it there. All right, scientists compared weights for a sample of African elephants to the weights for a sample of Asian elephants. So we're given a dot plot. Although the comparison analysis can be found, the dot plot and the data have been lost for the Asian elephants. Draw a possible dot plot for Asian elephants that fits the comparison. All right, this one is pretty hard. But we're gonna really wanna ask, pretty much the exact same questions we asked before. There is one other question we will wanna ask because we are making a dot plot. And that question is going to be how many, elephants were sampled, because if I want to make the dot plot, I have to know how many dots to put. So that's the one additional thing we'll make. All right, but this one I'm just going to try and go through a little bit quicker. All right, so if we look at all this information here, let's let's label it 1, 2, 3, 4, 5, and 6. Okay. Actually, before we do that, what I really want to do, because I'm given this dot plot, and I really should do this right away. If I know all this information about the population, I should put that into my calculator and find out exactly what the standard deviation is, what the mean is, all these things that I can find out on my own. I actually don't need to ask this person with the data card any of this information, because I can find it out using one bar stat. Oops. Hopefully I put all those numbers in correctly. It looks like I have the right number of places. Okay. So, got a mean, also known as X bar, 10,000. And that makes sense. I actually didn't even need to use my calculator for that, because look at this. Got 10,000, and it's a symmetric distribution, right? So the mean and median are going to be right in the middle. So actually, without even checking, I know my median is going to be 10,000 pounds as well. Standard deviation, that is something I can't tell just by looking. And my standard deviation there is 577.35. Okay. And that's really all I need to know for a dot plot. I guess the min and the max I already know, so that's not something I can find out on my own. Let's double check that median just to be sure, and it is. So I can tell this is a symmetric distribution. So I would want to know when I'm making the other graph how the distributions compare. So where out of these 6 options is going to help me with my distribution? And so hopefully number 5 tells you that the shape of the distributions are the same, and that means that I'm going to have a bell-shaped or symmetric distribution for my Asian elephants as well. Okay, actually, they give some information for the African elephants here. They told us that it's a standard deviation of 577.35 pounds. Okay, so if they give us the standard deviation for African elephants, they also tell us that the standard deviation for Asian elephants is less than the standard deviation for African elephants. So this standard deviation we see here is going to be greater than the one down here. This one is going to have a less of a standard deviation. So does that mean that my graph is going to be more spread out, or my graph is going to be less spread out? All right, so if my graph is a lower standard deviation, that means the less spread out, more closer together. So that's what 4 is telling us. 2 and 4 give us that information there. I do know that the shape is the same, so it's going to be the same relative shape, just a little bit pushed together. All right. The mean weight for the Asian elephants is 2,000 pounds less than the mean weight for the African elephants. So if that's true, what is the mean weight for the Asian elephant? Okay, so if it's 2,000 less, the mean weight is going to be 8,000. And that's really going to tell me where I can put the center of my graph here. I know that I've got 9 individual elephants in both samples, so it's going to be the same number of dots, the same shape, just slightly smaller or more compact. So let's say instead of, they don't tell me the min and the max, so I can really sort of take some liberty with this. I'm not going to do anything too drastic. Let's make this 7,500. Let's make this 8,500. I'm just going to move it in like this far. So the standard deviation would probably be about half if that was the case, because this one spanned 1,000 in both directions. This one only goes 500 in both directions. All right, so that would be a pretty good one. I think you could, say it's a little bit wider, a little bit smaller, depending on how you interpret the standard deviation, but that could be how we express the dot plot for Asian elephants. All right, that's all for 13.2.